Hi everyone, this is cost volume profit, and it's the next chapter beyond our exam that we have to do, and it's probably one of the most important chapters in the book. So if you've got the situation where you can actually work, it would be real good to spend some time on this, and in any event, don't blow it off, okay? So this is starts out on cost behavior, and it talks about how costs change in relation to volume. And the reason why this is important is because it allows us to forecast what sales will be, or what what we might get if we start a new project or a new product line. It allows us to forecast what the costs will be on it. All right, what we can expect to pay. So the first thing that we do is we're going to break our costs down in three broad categories, okay? Variable, fixed, and mixed cost. And we've talked about these before. This kind of formalizes it a little bit. So variable costs are costs that change in direct proportion, okay? In costs that change in total in direct proportion to changes in volume, okay? Not per unit, but in total. So every time I've got another unit that we produce, I've got another unit of variable costs, and that total cost would increase, okay? So the total costs change in direct proportion to changes in volume. The costs per unit remain the same, okay? So cost per unit will be the same, and we'll take a look at some charts that illustrate that. And when you're graphing, the line begins at the origin, okay? At 0 units of output. So at no output, our dollar amount would be 0. Whereas a fixed cost, even with no output, you'd still have fixed cost. Okay, that's what's so different about them. So with fixed costs, costs that do not change regardless of changes in volume. But this isn't like locked in stone. If only within the relevant range. Okay, so that if you say double or triple your capacity, your usage of a plant, and you can't do it within your existing plant, then you've increased your fixed costs. Okay, so it's just something that we say do not change regardless of changes in volume, and then here it should say within the relevant range. Okay, and assumes the total costs remain unchanged. And we're going to take fixed costs and divide them into two other categories. Committed fixed costs, costs that you're just locked into that cannot be changed. Depreciation is the perfect example. Okay, you can't just sell a building overnight to reduce your depreciation expense. Okay, and then we've got discretionary fixed costs, and these are costs that are annual management decisions. The best example is advertising or marketing. This is something that we can cut if we have to. Not always a good idea to cut it, but we might have to do it. So these costs are fixed in the short run, okay, but we can change the cost in the long term. Okay, so just committed versus discretionary costs. Now, in the cost per unit for fixed costs, these are going to increase as volume increases for fixed costs. I said it backwards. Cost per unit will decrease, okay? So as your denominator increases, that cost per unit is going to decrease. All right, as costs increase. And when graphing, the line begins on the intersect on the y-axis. Okay, not at 0. It'll begin where those total fixed costs are. And then the last category is mixed costs, and these are costs that change in total, but not in direct proportion to changes in volume. It has both fixed cost and variable cost components built into a total cost. So at one time, cell phones have maybe a base rate, and then they increase. Okay, so a base rate would be your fixed cost, and then they'd increase with usage. That would be your variable costs. Okay, so they increase as volume increases, but not in direct proportion because there's this fixed component. All right, so when graphing, the mixed costs don't begin at the origin. They intersect where the fixed costs intersect the y-axis, and then the variable costs go on top. So we'll look at some charts here. I don't know if they're in this group. I don't think so. Okay, so we've got a couple other categories, or a couple other things that are really important. The first thing is the cost equation. And just about every problem that you do in this area, in this chapter, results in you having to prepare the cost equation. And it's the same as the slope of a line that you had in high school, okay? Cost behavior. Okay, in this case, y equals your total cost, and that would be equal to your variable cost times number of units plus your fixed cost. All right, and that's what gives you your slope. It gives you the actual slope of the line, the variable cost does. All right, and the relevant range is the range in which volume and assumptions about cost remain constant. That's the relevant range. So other cost behaviors that we've got, a few other ones in here. We've got step costs. You should be able to visualize this or to draw it, but it's a fixed cost over a small range of activity. Then it steps up to a new range. A better example than, I don't know what we have here for Child Care Center, but would be if you had another shift at work and you had to add more supervisors, okay, or maybe a new foreman on a line, okay, that would be another hunk of fixed costs. Now curvilinear costs have a bit of a flow in them, you know. These are not linear, and we approximate these costs like mixed costs, but we're not going to have to worry about this. And then the last one is sunk costs, and sunk costs are anything that's in the past. If it's in the past, it's irrelevant, okay? So in determining cost behavior, managers need to determine the behavior before they can make predictions and good business decisions regarding costs and pricing, etc. Now, these are different ways of figuring out how costs behave. The first one is account analysis, and managers use judgment to classify accounts on the general ledger. So you literally go down a trial balance and you pick out which costs would be fixed, variable, or mixed, and then take it apart into its cost function. It's very informal. It's not great information because we use broad categories and you guess at the behavior. Okay, you can use a scatter plot to try and track costs to determine if they're fixed or variable, but this is one way to do it. Okay, another way to do it is using the high-low method, and I think we do regression in here. Yeah, do the high-low method, and that is we look at the data, we take the high level of activity and the low level of activity, and take the difference in cost divided by the change in activity, and that will give us our variable cost. Okay, now here's an example of it down below. Here is our data, and we've got January through April. If you look just at volume, okay, not at cost, but our high volume of activity is 480, so this would be our first one right here, okay, and then our low level of activity is 240, so this would be the low. So what we're going to do is take the always dollars over units. Our high dollars are 1960 minus 1480 our low dollars gives us 480, divided by the change in units of 240 gives us $2 per cookie. So what are we doing here? We just took, if any of these dollars are changing, it would have to be due to variable cost, right? Okay, because the fixed costs don't change, so any change in dollars because of changes in volume, we're saying is because of variable cost. So we took it apart here, change in dollars over the change in units, and we've got $2 per cookie. All right, that would be our variable cost. Now if we substitute that $2 back into this formula for a line, we can figure out what our fixed costs are. So we can take either level, either the 1960 or the 1480. So in this case we're taking 1960, and that would be equal to $2 times 480 cookies, right? That's our volume, yeah, plus our fixed cost, and our fixed cost ends up to be 1,000. If we do it at the low level of activity of 1480, that would be 1480 equals 2 times 240 plus B, your intercept. You're still going to get the same 1,000. Now this is, you can use either one. It'll give you the same answer. So I usually do the one that has the easiest math, But, what was I going to tell you? Oh, you can't use any other value. Only the high or the low. So what, in effect, we're doing here is drawing a line between the high and the low level of activity. Okay, that's what it does. And it's one way to estimate it. It's not perfect, but it's one way to do it. Okay, and then the last method that we're going to use, is regression analysis. And that helps determine the best fitting line by taking into account all of the data points. So the difference between high and low and regression is that regression uses all of the data points, whereas all of the data points, whereas high-low only uses the high and the low. Okay? Now, what do you need to know for this? There's an exhibit in your text with an example of output on here. But one of the statistical results that we're looking from a regression analysis is the R-squared. And the R-squared determines how well the line fits. Okay? In other words, how strong is the relationship between costs and volumes. If you get a 0, if you get an R-squared of 0, that would be absolutely no relationship, and 1.0 would be perfect. Okay, so the y-intercept is where the line intercepts the y-axis, that's your fixed cost, and the x-intercept coefficient is your variable cost. Okay, so we'll look at some output from a regression, and then as long as you're able to interpret some basic statistics on here, you'll be all set. All right, and one thing to remember is that cost equations are only as good as the data that the equations are based on. So this means that predictions are meaningless if the data being analyzed has no relevance to the costs being analyzed. Okay? All right. So let's, the last thing that we've got to do in this chapter, well, we've got a couple big things. First of all, we'll review an income statement approach again using the contribution margin, and then absorption versus variable costing. All right.